Okay, so at this point we've already learned the names of the angle relationships and how to locate those angles given two lines in a transversal. So we are going to identify special relationships when the two lines that are intersected by the transversal are parallel. So you'll need about 4 different color highlighters and you'll need your graphic organizer. So it should look like this at this point. So the first thing that we're going to do is open up the right flap that says when lines are parallel, corresponding angles are. But first we're going to use our highlighter to identify the different sets of corresponding angles. So remember, corresponding angles are in the same location, they're just on a different line. So for example, angle 2, go ahead and highlight angle 2 in one color, corresponds to angle 6. Angle 1, top left corner, corresponds to angle 5, top left corner. Angle 3, bottom right corner, corresponds to angle 7, bottom right corner. And angle 4 corresponds with angle 8. So your matching colors are your corresponding angles. The relationship when the lines are parallel, so if you have parallel lines denoted by the arrows, then corresponding angles are congruent. Okay, go ahead and open up this flap right here. Okay, so if you notice on the left hand side here, you have a pair of missing corresponding angles beneath 1 and 5. So we're going to go ahead and see an example of corresponding angles being congruent when the lines are parallel, as you can see here. So let's just say the angle beneath angle 1 is going to be 3x minus 14 degrees, and the angle below angle 5 is going to be 2x plus 25 degrees. And as you can see, they are in the same location, the bottom left corner of the angles and the bottom left corner, so they are corresponding. The two lines M and N are parallel, so because they are parallel lines, corresponding angles are congruent. And as an equation, then we would say 3x minus 14 is equal to 2x plus 25. So I would like for you to take a second, solve for the value of x, and see if you get what I get. And you should get x is 39. So then what we do is we come back to our expressions and make sure that these two are in fact congruent. So 3 times 39 minus 14 gives us 103 for this angle. And then 2 times 39 plus 25 gives us 103 for this angle. So as you can see, they're both obtuse. They both equal 103 degrees. Okay, go ahead and open up your next flap where it says alternate interior angles are. And let's identify our alternate interior angles. Remember, they're interior, so they're in between lines M and N. Here's lines M and N. So they're interior and they're on alternating sides of this transversal. So an example would be angle 4 and angle 6. And then another set would be angle 3 and angle 5. And the relationship that's special when these lines are parallel is that alternate interior angles are also congruent. So if you open up the flap next to alternate interior angles, let's go ahead and see an example of this. Notice we left the alternate interior angles beneath 2 and on top of 8 blank, and that's because we're going to put in some expressions here. Let's say that this angle is 5x plus 7 degrees, and this angle here is 7x minus 21 degrees. And notice they are both acute, so that's another clue that when the lines are parallel, alternate interior angles are congruent. So the equation that we would set up in order to solve for x would be that angle 5x plus 7 is equal to angle 7x minus 21. Okay, go ahead and pause the video. Make sure that you get what I get once you've pressed play again. Okay, so you should have gotten that x is 14. And what you do is come back into the expressions and make sure that the angles are in fact congruent. So we would do 5 times 14 plus 7 and then we would do 7 times 14 minus 21, and the two angles should both be 77. So because they're both 77 degrees, we know that we did this problem correctly. Okay, then we have alternate exterior angles. So before we identify the relationship, let's go ahead and highlight our different pairs of alternate exterior angles. Alternate exterior on the exterior of these two lines. So they're out here, and they're on alternating sides of the transversal. So we have angle 2, which is alternate exterior to angle 8, and then we have angle 1, which is alternate exterior to angle 7. The relationship that exists when the lines are parallel is that alternate exterior angles are also congruent. So if you notice on the left-hand flap, we have a pair of alternate exterior angles that have been left blank, and we're going to go ahead and say that the one in the top left corner is 4x degrees, and the one in the bottom right corner is 36 plus x degrees. And if alternate exterior angles are congruent, in order to solve for x, we would once again set 4x equal to 36 plus x. I would like for you to solve for x in this equation and then substitute your x back in and tell me what each angle measure is. Pause the video and see if you get what I get. So you should get that x is 12 and each angle measure is 48 degrees. If you did not get that, raise your hand and ask for help. Okay, so now we get a little bit tricky. Let's talk about consecutive interior angles or same side angles. So same side interior angles are in between these two lines and they're on the same side of the transversal. So you have angle 3 and angle 6, and you also have angle 4 and angle 5. And the different property about consecutive interior angles is that when the lines are parallel, that consecutive interior angles are supplementary. And you can even see this relationship. Angle 3 is acute, angle 6 is obtuse. So there's no way that they're going to be equal. This time they're going to be supplementary. So that of course means that the two angles are going to have a sum of 180 degrees. So let's go ahead and do an example of this. Let's label our consecutive interior angles here that were intentionally left blank. Let's make the obtuse looking one 3x plus 5 degrees. And the acute looking one 2x plus 10 degrees. So here, if the consecutive interior angles are supplementary, remember that means that they have a sum. So sum, add them together, 3x plus 5 plus 2x plus 10. They have a sum equal to 180 degrees. So now I'd like for you to take a minute, solve for x in this equation, and then substitute the x back into each expression and make sure that they are in fact supplementary angles. Okay, so we should have gotten that x is 33. If you did not get that, raise your hand and we'll come over and help you. And then once you substitute x back into each expression, you get 104 and 76 degrees, which is equivalent to 180. Okay, and the last angle relationship is consecutive exterior angles. Let's go ahead and highlight our consecutive exterior. Remember, exterior means outside the two lines M and N. So consecutive meaning on the same side, we would have angle 1 and angle 8. And then we would have angle 2 and angle 7. And if the lines are parallel, notice again that one is obtuse and the other is acute. And if one angle is obtuse and the other is acute, then that makes consecutive exterior angles supplementary as well. Okay, so then let's go ahead and see this as an example. Oops. All right, let's go ahead and say that these consecutive exterior angles, the top left corner is going to be 2x plus 30 degrees, and this bottom left corner is going to be 8x minus 40 degrees. And so once again, if consecutive exterior angles are supplementary, then that means that these two have a sum. So 2x plus 30 plus 8x minus 40, they have a sum of 180. Go ahead and take a minute, solve for x, then substitute your x back into each angle expression, and then see if you get what I get. So you should get that x is 19. If you didn't, raise your hand and we'll come over and help you. And then that the acute angle is 68 degrees, the obtuse angle is 112, and that, my friends, 68 plus 112 is 180 degrees.